Well, welcome to the second part of our lesson on right triangle trigonometry. In this lesson, we're going to learn how to use our calculators to find values of trig functions. We're going to be using some inverse trig functions to find angle measures. Our last lesson, we pretty much focused on finding the lengths of the sides. So in this lesson, we'll learn how to find the lengths of the angle measures. And then we're going to be doing what's called solving a triangle using our trig functions. And lastly, using the trig functions to solve real-world problems. So first off, to use a calculator to find some trig values, there's a couple of things that I need to make you aware of. One of the things is you need to make sure that you are in degree mode. Why this is jumping on me. Make sure that your calculator is in degree mode, so go to your mode button right here. You're going to hit that and then make sure you're in degrees and not in radians. So that's the first thing to just double check while we're working with the calculators. And then we're also going to be just finding values. So if we wanted to find, for example, the cosine of 46 degrees, you're just going to hit on your calculator, you're going to hit cosine and then 46 and then enter, and it's going to pop out for you just a value of some big long decimal number. And normally we'll probably go to 4 decimal places. But I'll try to remember in our assignments to tell you how many decimal places to round to. And then if we want to find any of the reciprocal functions, those were the secant, the cosecant, and the cotangent. Those we need to use this x to the minus 1 button. I have that highlighted in yellow right here. You will notice on your calculator there's a second function of your sine, your cosine, and your tangent function. Okay, those are going to be used, those are the inverse functions, not the reciprocal functions. This is very, very confusing, so I hope you're listening instead of just watching. I hope you're doing both. These inverse functions are used to find the angle measures. When we're wanting to find a trig value of an angle measure that is a reciprocal function, we have to use the original function and get that value and then just find the reciprocal of the answer. Okay, so if I want to find the cotangent of 20, the way that I do that is I hit the tangent of 20 and then hit enter, so it'll give me the tangent of 20, and then I'm going to do the reciprocal by hitting x to the minus 1 and then hit enter again, and it gives you 2.7474. Let me know if you have questions on that in class. So in our last video, I mentioned that we would be solving triangles. When we talk about solving a triangle, what we mean is that we are actually looking to find the lengths of all of the sides and the measures of all of the angles in the triangle. The minimum amount of information that you need to solve a triangle is you need at least 2 side lengths, or you could have 2 sides and one of the acute angles. As long as you have the minimum of that amount of information, you can solve the triangle. So let's go ahead and jump in and see what that looks like to go ahead and solve a triangle. This example says solve triangle XYZ, and we want to round our angles to the nearest degree. We want to round our side lengths to the nearest tenth. So first of all, the easiest piece of information to figure out is to find what the value of angle Y is. So angle Y down here, we know angle Z is 90 degrees and angle X is 35 degrees. And we know that the sum of any 3 angles in a triangle is 180. So if we substitute in the 35 and the 90 and then subtract that sum from 180, we end up with angle Y being 55. So that's probably the easiest piece to solve for. Then we got to find the lengths of our sides. So if I want to find the length of side X, well, I'm going to relate it to this 35-degree angle. X is opposite the 35-degree angle, and then the side length that's given is the adjacent side. So what trig function could I use with opposite and adjacent? Well, I have 2 choices. I could use the tangent function or the cotangent function. It's best to keep your variable in the numerator, so I'm going to choose the tangent function. So the tangent of 35, I'm standing right here at the 35-degree angle. The tangent is the opposite, which is x, over adjacent, which is 10. So if I want to solve this for x, I need to get rid of the 10. So multiply both sides by 10, and x is equal to the tangent of 35. And now it's a calculator problem. Plug in tangent 35 degrees and hit enter, and multiply it by 10, and you get approximately 7.0. If we want to find z now, we have two options. We could use the Pythagorean theorem, and we could go 10 squared plus 7 squared and take the square root. Okay, or we could use another trig function. Okay, usually you don't want to use a trig function that involves something that you just solved for, because if you make a mistake and get the wrong answer there, then the second one will be wrong. So what trig function could we use that uses the adjacent side and the hypotenuse? And that would be the cosine function or the secant function. And remember, we want to keep the variable in the numerator. So if I used cosine, I would have the cosine of 35 is equal to 10 over z. So I'm going to choose the secant function so that I can keep the z variable in the numerator. Multiplying both sides by 10. Whoops, I need to redefine the secant as 1 over the cosine, so that's a reciprocal function. And then multiplying by 10, we get z is equal to 1 over the cosine of 35 degrees, and we still need to multiply that by 10. So, I forgot to delete that one. Let's see what we have here. So z turns out to be about 12.2. The way you're going to plug this in on your calculator is you're going to take the cosine of 35 degrees and then hit enter, and then hit that x to the minus 1 button that I talked about in the last slide. And then that will give you the secant of 35 degrees, but then you have to multiply that by 10. So I believe 12.2 is the correct answer. If it isn't, let me know in class and we'll take a look at that. Here's one for you to try. Go ahead and solve triangle FGH. Pause the video to do that, and then bring your answers to class. All right, let's go ahead and move on with our next objective here, to find the missing angles using inverse trig functions. So if we want to solve triangle ABC, this time we are only given side length. So we are going to have to use inverse trig functions to find the angle measures. And first of all, let's try to find angle A, just randomly. We know angle C is 90, so we need to find angles A and B. So angle A, I can use any of the trig functions using any of the sides. So in this one, I'm just going to randomly choose to find the sine of angle A. And the sine is equal to the opposite over hypotenuse, so it's 5 over 13. So now if I want to get rid of the sine part of this, algebraically, here's what happens, is I take the inverse sine of both sides. So I take the inverse sine of A and the inverse sine of 5/13. And this inverse sine and the sine function are opposites. They are inverse operations, and these two things cancel out. So I am only left with, then, on the left-hand side, I'm left with A is equal to the inverse sine of 5/13. The way that we read this is called the angle whose sine is. So A is the angle whose sine is 5/13. So what you're going to do on your calculator is you're going to take 5, divide it by 13 and get an answer, and then do second sine. Okay, so that's where the inverse sine is on your calculator. It's a second function of the sine function. And then round that to the nearest whole degree, and you get about 23 degrees. Okay, now angle B, once you find angle A, you could subtract from 90 or subtract from 180 if you add all three of them together. And that's what I'm going to do here. I'm going to take 23 plus B plus 90 is 180. One of the things you should notice on this is the two acute angles will always add to 90 so that we get a total of 180 in our triangle. So on this one, we get B is approximately equal to 67 degrees. The reason it's approximate is we approximated angle A, so we also have to say that B is an approximate answer. In our last example here, our last slide, we have an Army Corps. Actually, we've got one more slide after this, don't we? An Army Corps of Engineers is making a bridge, and they want to construct this bridge across a river. So let's suppose we're going to pound stakes in on each side of the river. Okay, W is the width of the river here. And 50 meters from one of the stakes, they take out their equipment, their surveying equipment, and they measure an angle of elevation, or an angle of 82 degrees is measured between the two stakes. Find the width of the river. Well, the first thing you need to do, if you're using the angle of 82 degrees, if that's where your reference is, that's where you're going to be standing, what sides are you dealing with? W is the opposite, and 50 is the adjacent. So what trig function uses opposite and adjacent? And that would be the tangent function. So then I can write an equation. The tangent of 82 degrees is equal to the opposite over the adjacent, which is W over 50. If I want to solve that for W, I multiply both sides by 50, and I get W equals 50 times the tangent of 82 degrees. Make sure that you're in degree mode again. Take the tangent of 82 on your calculator and then multiply it by 50. And the width of the river to the nearest tenth is about 355.8 feet. And lastly, here we go with the angle of elevation and depression. An angle of elevation is an angle that's measured up from a horizontal reference line. So once you have your horizontal line of reference, if it's going up, it's an angle of elevation. If it's going down, if it's an angle of depression. So let's see how we would use that in the real world. So let's suppose we're going skiing, and we're going to go skiing in Snowbird, Utah, and we are going to go down the aerial run. And we are told this aerial run has a vertical drop of 2,900 feet, and it has an angle of elevation of 20.2 degrees. They want us to find how long L is the run. So we have our right triangle in our picture. So we need to figure out if 20.2 is where we're standing, that's our reference angle. What sides do we know? We know the opposite side, which is 2,900, and we're looking for the hypotenuse. So opposite and hypotenuse is the trig function sine. So we're going to use the sine of the angle, sine of 20.2 is equal to opposite over hypotenuse. Now I could have used the cosecant function as well, but I'm just going to show you how to use the sine function when you have your variable in the denominator. If I multiply both sides by L, okay, I can get that L to cancel over here on the right hand side. And so I'm left with L times the sine of 20.2 is equal to 2,900. And then I need to divide both sides by the sine of 20.2. So just to give you an idea of what's going on here, take this side and divide it by sine 20.2 degrees, and do the same thing over here, sine 20.2 degrees. So we have 2,900 over the sine of 20.2 is equal to, so these two would cancel over here, is equal to L. It's a little bit confusing there, sorry about that. So once we do that, we have L is equal to 2,900 divided by the sine of 20.2 degrees, and then do the sine of 20.2, get that answer, okay, on your calculator, and then do that reciprocal where you use the x to the minus 1 button, and then multiply by 2,900, and you'll get 8,398.5 to the nearest tenth. That'll do it for this video. We'll see you in class.